Hello everybody. Today I'm going to show you guys how to solve the 4x4 parities. Now, you can be going along, you're solving the 4x4 or 3x3, and when you're done with these layers, you see this. Now, we all know on the 3x3, we can either have a dot, an L shape, a line, or a completed cross. But what you see is this sort of like I shape. Or you can also see something like this. Try and get it. Come on. Still an eye. Okay, here we go. Or you may see this sort of like T shape. Okay, let me go back to the eye. Eye shape. Alright, so we're back at the eye. Now, in case you forgot, what a parity is something that does not show up on the 3x3. Again, we can either see a dot, L, line, or shape, or a cross. But again, we see an eye. We never see an eye in the 3x3, so that's called a parity. Now, we need to solve this parity. Now, this parity here, this is called the edge parity. There's also a corner parity that comes in a little bit later. It's like the next step. Now, to solve this parity, we see this. This is flipped over. So if we flip this one over, it'd form a line. Or if we flip one of these two side ones, it'd form an L shape. I'm going to form a line. So, to memorize this algorithm, we're going to be using these right and left wedges here. So just make sure every right wedge movement is going to be associated with a double top spin like this. Okay? And every left wedge movement is going to be associated with a double front movement like this. Okay? So that's a hint for memorizing. So now let's get down to the algorithm. So here we go. It's going to be the right wedge down once, spin the top twice, bring down the left wedge, spin the front twice, bring back up the left wedge, spin the front twice. Okay, now we're done with the left wedge. Now I'm going to spin the right wedge twice, spin the top twice, bring up the right wedge, spin the top twice, bring the right wedge back down, spin the top twice. I'm going to spin the front twice. Then you spin the right wedge twice. And then spin the front twice. So now we have this line. And that's normal on a 3x3. So now, all you gotta do is get your cross. And then align it. So, I'm just gonna do that. I'm trying to do that simply as quick as possible. There we go. So now, our cross is done, and now we're on the corners. Hold on a second. I'm actually going to force my parity here. Oops, no. The orange. Okay, so now here we see this second parity. We see now, y'all know on the 3x3, when we're done with the cross, you can either have 0 corners placed correctly, 1 corner placed correctly, or all 4 placed correctly. We never see 2, so this is the second parity on the 4x4. Again, the reason why we get these parities is because we can move these centerpieces. So that's why we get these parities. So to solve this parity, all we're going to be moving is this right wedge, a top, and a double top. Right wedge, double top, double top, and this upper wedge like this. So there's a top slice. So this algorithm here is as follows. Oh, I forgot. If you have if your two corners are placed correctly, are like this, like they're right next to each other, then you'll hold the cube so that they're both facing you. But if they're diagonal, you can hold it any way you want, as long as the blue is facing up. So this algorithm is as follows. I'm going to move the right wedge twice, then you want to spin the top twice, you need to move the right wedge twice again, then spin the double top twice, then move the right wedge twice, one final time, and spin this top slice twice. So now you see you preserved your cross, but you kind of broke up your alignment. So once you realign this cross, you can just solve the rest of the cube like a 3x3 because all your parities are solved and it'll be done. So thank you for watching, everybody, and I will put the algorithms down in the description below. And I hope you see, and as always, I'll see you guys next time.